So right here, we've got 3 to the a power, or 8th power, I guess, is, I don't want to confuse it with the number 8. 3 to the a power is equal to the 5th root of 3 squared. And what we need to figure out is, what would a be equal to? Let's solve for a. And I encourage you right now to pause this video and try it on your own. Well, if you have a 5th root right over here, one thing that you might be tempted to do to undo the 5th root is to raise it to the 5th power. And of course, we can't just raise one side of an equation to the 5th power. Whatever we do to one side, we have to do to the other side if we want this to still be equal. So let's raise both sides of this equation to the 5th power. Raise both sides to the 5th power. Now, this left-hand side, we just have to remember a little bit of our exponent properties. 3a to the 5th power. And if we want to just remind ourselves where that comes from, that's the same thing as 3 to the a times 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 3 to the a. Well, what's that going to be equal to? That's going to be 3 to the a plus a plus a plus a plus a power, which is the same thing as 3 to the 5a power. So the exponent property here is, if you raise a base to some exponent and then raise that whole thing to another exponent, that's the equivalent of raising the base to an exponent that is the product of these two exponents. So we could rewrite this left-hand side as 3 to the 5a power. 3 to the 5a power is going to be equal to, well, if you take something that's a 5th root and you raise it to the 5th power, then you're just left with what you had under the radical. That's going to be equal to 3 squared. So now things become a lot clearer. 3 to the 5a needs to be equal to 3 squared. Or another way of thinking about it, we have the same base on both sides, so this exponent needs to be equal to this exponent right over there. Or we could write that 5 times a needs to be equal to 2. And of course, now we can just divide both sides by 5, and we get a is equal to 2/5. 2 over 5. And this is an interesting result. And what's neat about this example, it kind of shows you the motivation for how we define rational exponents. So let's just put this back into the original expression. We've just said, or we've just solved for a, and we've gotten that 3 to the 2/5 power to the 2, and actually let me color code it a little bit because I think that'll be interesting. 3 to the 2 over 5 power, 3 to the 2 over 5 power is equal to the 5th root. Notice the 5th root. So the denominator here, that's the root. So the 5th root of 3 squared. 3 squared. So if you take this base 3, you square it, but then you take the 5th root of that, that's the same thing as raising it to the 2/5 power. Notice, take this 3, take it to the 2nd power, and then you find the 5th root of it. Or we could, if you use this property that we just saw right over here, you could rewrite this. This is the same thing. This is the same thing as 3 squared, and then you raise that, to the 1/5 power. We saw that property at play over here. You could just multiply these two exponents. You'd get 3 to the 2/5 power, and that's the same thing as 3 squared, and then find the 5th root of it. 3 squared, and then you're essentially finding the 5th root of it.